So I recently saw this picture by Robbie Kraft on Twitter of an origami Stanford bunny. Now looking at this, I initially thought this, this is geometry, this must be a render based on the triangulation, but it turns out that it's not a render. This is actually origami, and that's because Robbie is an amazing origami artist, and if you look through some of his other work, it's absolutely fantastic. Now, I am not an amazing origami artist. In fact, I know absolutely nothing about origami, but I do know that it looks really, really great. So I wanted to see if we could create this kind of a look inside Houdini and make it a relatively simple type of approach. So we're not making any folding patterns here, but instead we want to make a simple setup to convert an object into something that looks like it might be origami. So let's head over to Houdini. And inside Houdini here, I've got a very simple scene setup with a ground plane, I've got a few lights, I've got a shot camera, and in the middle there is an absolutely tiny Stanford bunny. So let's look through our shot cam and dive into our bunny geo container. And the first thing we want to do is make sure that this bunny is just a little bit bigger and centered. So let's drop down and transform. And these values worked for me, so there we go. So then we want that kind of a low poly angular sort of look. So we'll drop down a remesh, and the remesh will set to a single iteration. We don't want any smoothing, and we can keep the target size to 0.2. Now for me, the triangles here are still a little bit too small, but if you start increasing your target size, you lose definition in the ears and the face and the feet and the tail there. So that's not ideal. Instead, let's drop down a poly reduce and use this poly reduce to get rid of another, let's say 50%. So using this poly reduce is a nice little workaround to get a low poly mesh without losing too much of your detail. And for the origami setup, we're going to want to work on each prim separately, but at the moment each prim, the points are shared between prims, and so we want to drop down a facet sop and we want to highlight the unique points there, and what this does is that it creates those additional points. So now we've got 207 primitives and 3 points per primitive, and before we only had 108 points. Great, so now we can drop down a big for each, and in this for each loop we're going to do the main setup. Set the for each loop to primitives and click on a single pass. You can see that highlighted first, you can go through each individual primitive and manipulate it. Now the first thing we want to do is we want to create a meta import node, because inside this meta import node it'll create a detail attribute with the iteration that we're working on, and so that's something that we can use as a random seed for our effects later on. So we're going to want to apply a paper texture to this, and for that we need UVs. So let's drop down a UV texture. If we just drop it in here, it'll apply the UVs uniformly across it, and then across the different folds our UVs are going to line up perfectly, and that's not what we want. Instead we want to create a bit of randomness and break it up a little bit. So in this UV texture, what we want to do is we want to add a spare input, and in that spare input we want to drag the metadata node. And what this means is that we can now access that detail attribute with the iteration counter from the metadata input node into our UV texture. So what we want to do now is we want to change the angle of the UVs between each of these prims. So for our angle, we need to have a detail function to look at the -1 input slot, which is the spare input slot. We want to look at the attribute iteration, and we want the first component of that. So now this is just the highest prim number. If we set it to our single pass, we can see that's now just reading out that iteration number. Instead, we want to use that iteration number as a random seed. So we can add a rand function to it, and then we want to go ahead and fit that random number that is between 0 and 1. We want to fit it between -360 and 360. So that gives us a random rotation angle for each primitive for its UVs. And so that's going to really nicely break up our UV texture. The next thing we want to do is we want to make sure that we only have large enough triangles. Sometimes the remesh and the poly reduce give you really, really small triangles that wouldn't look realistic as origami folds. So what we want to do is drop down and measure sop, and we want to measure the area of each primitive, and it's going to be output as an area attribute. Next, let's drop down a wrangle. We want to run this over the primitives, and let's first create a float slider with a threshold. So let's say And let's set this threshold to, I don't know, 0.0025, something like this. We can then put down an if statement. If the area that we calculated with the measure sop is smaller than the threshold, we want to remove the prim that we're currently evaluating, and a 1 indicates here that we're removing the prim and we're removing the points as well. So the next thing that we want to do is want to shrink back all of our prims a tiny little bit to give us a little bit more leeway when we start rotating and extruding and all those sorts of things. So for that we need a transform. In our transform we want the pivot of this scaling to be right at the center of each primitive. So let's put down a $CEX, $CEY and a $CEZ. It's the center of those pivot points, and let's scale it down by, let's say, 0.95. The next thing we want to do is want to rotate each prim randomly. For that, let's drop down a primitive sop, and we'll need to give that a spare input that will, as before, will drop down our for each metadata into it. And we'll also want to have a rotation multiplier as a float. So let's go into our add parameter interface. Let's take a float. Let's put it all the way at the bottom here as well. Let's call it rotation multiplier and then hit apply and accept. Okay, so now that we have our spare input and we've got our rotation multiplier set up, let's do the transformation. And we want to have access to our iteration. So that's a detail attribute coming in through slot -1 for the spare input. It's called iteration and it's the first component. And we want to use this as a random seed. So let's put down a random function and like so. Next, we want to multiply this with our rotation multiplier. So multiply it with the channel called rotation multiplier. There we go. And close it off. Great. So now we've got a rotation here. Let's copy all of this across to our Y and our Z. And if we start messing around with our rotation multiplier, we can see that now we're making every primitive rotate slightly with a different random seed for each and every single one. Okay, so next we need to start thinking about the folds and creases in our paper. So firstly, when you fold paper, it always sort of bulges out in the middle a bit from when you're handling it. So we want to create that kind of a bulge. We don't want perfectly flat primitives here. In order to create that bulge, we ideally like to have a point right in the middle of each primitive. So if we drop down a subdivide, we can see that we're creating that point in the middle right there. So let's also drop down some point normals on here. Okay, so in order to do this deformation, we want to have a wrangle. And so if we have a look at an individual primitive here and we check the point numbering, you can see that point number 3 is always the center point. So we want to work with point number 3. But first, before we do that, we need an offset float. So let's create a slider so that we can control how far we want to push that central point in or out. And let's set this to 0.03 maybe. Then we want to read in some of these attributes of that central point that we want to move around. So let's create a vector pos and let's read out the position input slot 0, the attributes position, and we want to specifically only look at 0.3. Then we need a vector for the normal that we just created, and input slot 0, we want to look at the normal of 0.3. We need to have the iteration. So in order to get the iteration, we can, instead of using a spare input slot, we can actually just take our metadata and plug it into the second input slot here. So our float iteration, we can use a detail attribute to look at input slot 1, iteration, and then the first component. We want to use that iteration to create something random. So let's say float rand equals random based on the iteration as a seed. And we then want to offset that randomness by creating a float offset rand, where we fit our rand function that goes from 0 to 1. We want to fit that between minus offset and offset. We now want to create a new position, call it vector npos for new position, and we want that to be the original position plus the offset rand that we just calculated multiplied by the normal. And so what that means is it'll offset it along the normal, either inside or outside. And then it's just a matter of setting the point attribute on position of point number 3, and we want to set it to that npos that we just calculated. And so if we zoom into this point a little bit further, we can see that by manipulating the offset, we can create this sort of a bulge in the middle of our primitive. But obviously this isn't particularly smooth or high resolution, so let's just drop down a subdivide here, and let's set it to a depth of 2 to smooth it out a little bit. And we can turn off our point display and look at the entire thing again. Okay, so now it's broken up a little bit and it's looking a little bit more organic. So the next thing I'd like to do is take the corners of these primitives and fold them inwards a little bit. So in order to fold in those outer corners of each of the primitives, let's have a look at the point numbers again. And so if we just hit a single pass and highlight the point numbers and zoom in a little bit, we can see that the corners are always points 0, 1, and 2. So essentially the only points that we want to manipulate are those 0, 1, and 2, or in other words, everything that's smaller than 3. So to do this, we can essentially reuse that same attribute wrangle that we created here, but we want to tweak it a little bit. And so instead of running over point number 3 like we did here, we want to only run over the points that have the point number 0, 1, and 2. So let's create a for loop. Let's run it over a counting variable I. As long as I is smaller than 3, we want to increment I. And then let's indent this a little bit so that we can see what we're doing. Okay, so we don't want to have it run over point number 3, we want to have it run over point I. And there we go. Now you see that each of these corners is either pushed in or pushed out. Let's exaggerate it a little bit. Okay, so I forgot one little eye there. But again, this is a little bit harsh, so let's drop down another subdivide to help smooth things out a little bit. Okay, so now we are ready to extrude. So again, we want to extrude each of these primitives in a slightly different way so that we create a little bit of variation. And by extruding it, we give it some thickness and we make it look like it might be folded back onto itself. So let's add a poly extrude. Again, we'll need a spare input and we want to have that metadata in our spare input. Just drag and drop it in. And we want to vary the distance that we're extruding. And so for that, let's put down a fit. Inside the fit, we want to have a random number generated based on the iteration. So it's a detail function looking up input slot -1, looking up the iteration and looking up the first component of that, like we've done before. And so this random function we then want to fit. It's going from 0 to 1, and we want to fit it to be between, let's say, 0.002 and 0.0075. And we want to extrude this along the point normal and output the back as well. Great, so now we have our extrusions. We're nearly there. I'd quite like to add a mountain sop to kind of break this up a little bit more. But this, you know, that's obviously a little bit too harsh. So let's tone it down a little bit and let's set the height to 0.0015 and the element size to 0.1, 0.003. Okay, so what we can do now is let's drop down a material. I prepared a quick redshift material with that texture that I was talking about, so let's call it the paper material, and let's head over to redshift and have a render. Okay, so there's a few things that we want to tweak. Those corners are a little bit extreme, so let's have a look at that first. So let's zoom in a little bit, maybe take down the offset here, say 0.01. And actually, I don't want to have this corner going either outwards or inwards. I basically only want them going inwards. So let's set the offset here to 0. Oh, wrong way around. Let's set it to minus offset and 0. That's better. So the next thing I want to tweak is the texture. And the UV texture, we shouldn't set it to orthographic. We should just set it to be face-based. Okay, let's grab our render view again. There we go. That's looking a lot better. Now, the one thing that I don't particularly like is that you have these areas where you can see through. So there's a few ways that we can fix that. One thing that you can do is by reducing the random rotation. Another thing that you can do is to reduce the amount that we shrink each primitive. And both of those would work, but it kind of makes the overall model look a little bit more uniform. And I like that the triangles don't line up perfectly. I think that gives it this sort of imperfection of it being done by hand. So let's find a little hack to close those gaps in between. So what we're going to do is right before our facet here, let's drop down a peak. And with this peak sop, we can slightly push out the geometry. And let's then copy it across. And in a second stream, let's slightly shrink the geometry. And we can use this slightly shrunken down geometry to merge back in. Let's pop down a null. and give it a new material as well. I prepared just a simple black material, and let's merge those two together. So now you have a model on the inside that's just completely black, and that'll cut through any of those kind of open areas. There we go. So let's compare that to the before and after. So it just looks a little bit more solid this way. And now we see that everything is fixed. So there you go. The main things that you want to tweak, if you want to tweak this setup, are the settings in your remesh and in your poly reduce, so you can have smaller or larger triangles. And then, of course, each of these kind of random rotations and scaling and the extrusion, those are all things that you can use to tweak it. And as always with Houdini, if you don't like this bunny, then you can grab trusty old pig head and you can plug in that pig head, and there you go. You now have an origami pig head. Great, thanks so much for watching, and catch you on the next one.